All right, but how can we collect data that I described? This huge amount of social media data, all this type of data that is available all across the internet. How can we find the way to collect it? I think that is one of the key important steps in our success in studying the world with the use of digital data. Finding the way to collect it is crucial for our success, I believe, in this endeavor. And that's why I really emphasize uh, importance of learning the best strategy for collecting data. There are a few issues with that. The first issue is that things change rapidly on the internet. Social media platforms change protocols of accessing their data. New platforms emerge, old platforms die. Things change rapidly, and that's why it's important to remain dynamic. It's important to follow trends, recent developments. And that's what I will talk about very briefly about what might be the best way for us as data scientists, as data analysts, to collect data from social media in an efficient way. And I would say, and many people perhaps would say so as well, there are two key data collection strategies that exist in relation to social media data and broader all type of internet available data. The first strategy is an older one, exists for decades, and it relates to this idea that essentially every single website can be accessed by a user, can also be downloaded to some extent. So all its content, all its images, pictures, links, text could be downloaded by a user on their computer. And that's what essentially is web scraping is about. Downloading all materials we're interested from all type of websites. The second way of accessing data, specifically social media data, but not only, is kind of more sophisticated approach, an approach that allows us to access the data through specific doors or windows or access points, APIs that are designed for accessing data, user data produced by users very often. On But big platforms have this access point. They maintain them for different purposes, mostly marketing purposes, to make the cooperation, coordination with third-party marketing frameworks easier. However, APIs become increasingly restricted in terms of accessing data. It becomes increasingly more difficult to access data through APIs. And in addition, in order to get data through APIs, as well as web scraping very often, it's important sometimes uh, to learn new tools, or even sometime code your own tool, or at least adjust it through coding. So let's look at an example, and this is the example of the first approach when we use third-party applications to download data from platforms. There are many of those applications. So here, with this approach, is the easiest approach of accessing data on social media platforms. Not every platform allows it, but in fact, I think there are a few of them that allow it, and Twitter, in this respect, is most one of the easiest platforms to access. You remember I mentioned that a lot of research on that uses social media data to discuss social issues relies on data from Twitter, and that's what those applications I display here do. They help us to access Twitter data without any difficulties. But the issue with those applications, very often they restrict how much data we can download. We cannot download all Twitter. Very often, data we can access relates to few recent sort of tweets on specific topic over a few specific recent days or hours. So not much data we can download in that respect on specific topic, though still quite a lot of data available. You use this approach. And importantly, everyone can learn about using those tools through tutorials available on the websites of those tools, of those applications, as well as through tutorials on the web, like on YouTube. YouTube is a great place to learn new things. Just go and learn if you're interested. What are the challenges of data collection? As I mentioned, platforms increasingly restrict access to them, and also user-produced data. There are many reasons for that. No time to discuss it. Move on. Data also is harder to analyze if it's produced or found on a multinational platform. So platforms like Facebook, YouTube, Instagram, used not just by one nation, by one type of people, not just by people who write in English, but all types of languages people use, all types of countries they're coming from. And sometimes it's not easy to analyze and combine data in different languages. Sometimes we need to distinguish different languages. We recently encountered that problem during our research on the messenger platform Telegram. We essentially downloaded millions and millions of messages on Telegram, public messages, and we found that most of the messages were not in English. They were not even in any language you spoke. They were in Farsi, in Arabic. It was impossible for us to read it. We didn't have that skill to read those messages. And it was also difficult to distinguish messages in different languages because, well, for many reasons. So it's an issue. Big data approaches also require more technical knowledge. So if we go down that way, trying to use social media to get to learn about society, we need to also learn new technical skills. And this is an example of one of the easiest APIs. So you remember the second way to access data, first through downloading web pages, and the second way is just essentially accessing those web pages through specific designated points. Those points aren't always open, but Twitter does quite well in that respect. But it's not the only way. See, Twitter API is just one of the ways to access data on Twitter. There are also other ways. For instance, as you see, there is something called FacePager that also allows you to access Twitter. If you're interested in Facebook data, of course, the largest platform, you might think of using something called CrowdTangle, we're just going to talk about in a second. Or I already mentioned FacePager, but I shall tell you, Facebook data becomes more and more increasingly difficult to get access to. If you're interested in more sort of visual content, Instagram might be something to look at. Again, CrowdTangle can be a solution. Reddit, also CrowdTangle, but also something called PushShift. And PushShift is essentially a database created by someone, a kind researcher, kind user who collects Reddit stories, collects information from Reddit, and then shares it with people. Let's move on. YouTube. YouTube is one of the easiest platforms to get data from. What type of data you can expect to get from YouTube? Let's think together. What do we often see on YouTube? Exactly, videos. Videos is one of the ways, one of the greatest things to get from YouTube, but apparently it's not what most people try to get from YouTube. In fact, most people who are interested in YouTube data try to collect something called metadata about videos, number of views, number of comments, likes, dislikes. That's what people get from YouTube, as well as comments themselves. And it's easy to collect using this tool, the link to which you can see on the screen. But one of the biggest frameworks that are used currently by quite a lot of researchers and people and data scientists called CrowdTangle. It allows to access Facebook data, Instagram data, and Reddit data. Sounds great, right? That's what we need. That's what we need, this data. But you know what? There are restrictions, obviously. And there are multiple. You can't get every bit of data from YouTube. You can't get all posts on whatever topic you want. In fact, you can get data only from public pages, groups that that are relatively large, or if it comes to Instagram, accounts with many thousands of followers. And it's those requirements change all the time. But then the biggest trouble with CrowdTangle is not that. It's not that thing that you can get only public data from pages and groups that are public and not private accounts, essentially, when it comes to Facebook. The greatest challenge of CrowdTangle is it's not available to everyone, unfortunately. Officially, there is an application process if you're interested in getting access to this framework, and you might be approved and might be rejected. Or just like me, you might never get an answer. And that's the restriction. The restriction here is that individual researchers or students normally don't gain access to this platform. This platform is sort of regulated by Facebook because, you know, Facebook, Instagram is the same company, and they don't really like to see that many people getting access to their data that easily. Not friendly, yeah? Though, if you're happy, if you're lucky enough, if you're privileged enough to get access to this platform, you might see something like this. You might see the level of, say, for instance, interactions over a specific period of time. This is the beginning of the pandemic in 2020. How many posts with keyword coronavirus been shared on big Facebook pages. Quite a lot of data you can get, and also you can download this data in CSV format and then analyze it to your pleasure. If you, again, not lucky enough, and as me as well, like me, you can't get that data easily, you can at least be satisfied with something called Chrome extension to CrowdTangle. It allows you to see kind of basic information on the webs in relation to a website or in relation to a web page from a website you are visiting. So for that, you just try it now. So go on Chrome, download extension called Chrome extension CrowdTangle, install it, and go on Washington Post page or go on Guardian page and check what you see and try to understand what is that, what it tells you. It's a good example, good exercise. It gets a basic idea of how very often social media data looks like. There should be some music sound in the background while you're doing it. All right, if you did it, thank you a lot. Let's move on. Yeah, let's move on to an example how we can use CrowdTangle data to analyze social problems and social issues. And the social problem for today that we're analyzing is disinformation, right? How disinformation spreads online. And here's an example of our study that analyzed problematic videos that were removed from YouTube for violating community guidelines last year. And all of the videos we looked at mentioned COVID-19 related words. So we call those videos COVID YouTube videos. What we found is that it took 41 days on average to remove videos containing false information for YouTube. So YouTube been thinking quite a lot before removing videos that apparently they decided in the end violated their community guidelines. So how we found those videos, how we found out that there is 41 days. It's an interesting case, interesting example of study that uses combination of several platforms. As just I mentioned, it's what we're trying to do. We try to get information from different platforms, not just from one, YouTube, but here we used Facebook as well. And here is an algorithm, what we did. So we started with 71 keywords that is related to COVID-19 pandemic, such as COVID-19, coronavirus, pandemic, and so on. We went on Facebook and used this crown triangle tool to download, find out every single post with a video from YouTube. How we did it, just there should be a link to YouTube, youtube.com or YouTube, something like that. Links to YouTube, and we found 1 million of such posts, and it's not all, it's just a portion of those links on Facebook. Then we went on YouTube and checked every single link and found that about 8,000 of them were removed, and YouTube tells us why videos were removed, and they were removed for breaching community guidelines. And then we went back to Facebook and asked Crown Triangle, as well as something called Wayback Machine. Do you know what Wayback Machine is? If you don't know, just stop the video and go and check what Wayback Machine is. We're moving forward in the meantime, and we checked on Facebook and Wayback Machine information about those 8,000 YouTube links, and looked at posts, looked at views. So it's not easy. YouTube doesn't tell you how many views a video that was removed had, but we managed to find out it through other means. Through Facebook, at least how many likes a post with a link to this YouTube video that was removed had, or Wayback Machine that essentially shows you a screenshot of a YouTube video before it was removed. We find out what was the level of engagement. Remember, we discussed level of engagement as a combination of likes, shares, comments, and a specific post on social media. And we also found out when the video was published and when it was removed through using API of YouTube. And we found out those 41 days is something that took YouTube video to remove those videos. But interestingly, we talk about disinformation here. You say, where is disinformation? This is actually one of the assumptions. This is an example of how we build models when we discuss social media data. Very often we cannot analyze and cannot read all of those 8,000 posts, 8,000 videos. We cannot check their content. So we just assumed, this is actually, I think, a disadvantage. I don't think it was the very right way to do, but we did it. We assumed that all videos that were removed during the period of pandemic that discussed COVID were removed because they contained misinformation about COVID, which not necessarily be true. They also might be about, they might just spread hate speech, for instance, not necessarily misinformation. So it was a very broad definition of misinformation. And in addition to this, you see there is a graph on the screen that shows you interesting stories, shows you relation between what shares on Facebook and videos on YouTube, or views on YouTube. So essentially, for those videos that have been removed, you see the growth in terms of views is linked, what we call correlated with shares on Facebook. In other words, when shares on Facebook increase, views also increase, look like. Not a big surprise, but this is what type of information we can learn if we try to download those massive millions of those videos, 8,000 metadata points from different platforms, combine it together, combine data from Facebook, combine data from YouTube, combine it in one graph and see this type of analysis. This is just, I think, quite simple example, but also quite good example. Another story about that shows how we analyze data from different platforms is here. This is an example of already mentioned by me study of Telegram, this messaging platform, and UK far right people. This is a bit more difficult kind of to explain because maybe many of you don't know what Telegram is, but the thing here is simple. Here we focus not on API, but we use API to collect data. But then what we do, we focus on links. We compare links across different platforms, links to articles, links to websites. And that's what is a key thing. That's often the key thing and the easiest thing to analyze when it comes to social media data. Links which points out towards the authorship, the source of data. And that's what unites data across different platforms. If someone shares an article to Guardian, the link to this article would look similarly across all platforms. That's how we can see similarities and differences. Read the story, read the abstract of this paper using the link provided here, if you're interested. And in the meantime, we move forward.